Hi, everybody. Welcome back to the Shuko Math Practice Lab, Learning Through Practicing. So we are continue doing the integrated by parts, and this is our practice number 3. And in this practice set, we're also going to talk about a very special type of the function. How do we use integrated by part to do the integrations here? So this is the part, when your function is inverse trig functions here. So here are the 3 different type of the inverse function, and we're going to practice and what type of the special skill or technique we need to use. So as always, you can pause the video right now and try to solve it by yourself to see you have any difficulty and where you get stuck. And afterward, resume the video and come back and I can show you how to solve it and we can check the answers. Okay, so now if you want, it's time to pause your video and do the practice yourself first. And I'm going to go to the whiteboard right now, okay? Hi, everybody. I'm back. I hope that you get a chance to do some of the practice and then we can check our procedures. Okay, in order to do the inverse trig function, first, I will, just like always, I will want to do a brief review and I'm going to write it out, a few special type of the derivatives you will need for the inverse trig functions here. So those are the formula. I hope that you still remember. So how about if you have a sine, arc sine, all right? So the arc sine is give you is 1/1 minus x squared. And then if you have an arc cosine, so arc cosine x is here, this will give you is -1, 1/1 minus x squared. Then the arctangents here, okay, so it will be 1/1 plus x squared. Those are the 3 most used ones here. Now let's do the other 3 here. So the cotangents, arccotangent x is here. This will be just a -1, 1 plus x squared. Then let's take a look at the dx for the secant, arc secant x is here. Right, so this one's here, this will be 1/x and x squared minus 1 here. Then the last one is the cosecant, arc cosecant x. So this is equal to the -1 x and x squared minus 1 here. So those are the 6 formulas about the inverse trig functions. And I think if you cannot remember the last 3, at least you need to remember the first 3 here, right? So those are the formula we're going to use when we try to do this integrated by parts. And also, like we talk about the integrated by part, the general formulas is like this. If you have a UdV, you want to change it to the UV minus VDU here, right? So those are the key formulas we're going to use for this practice set here. Okay, so now let's take a look. Let's start with the easiest one. It's the problem A here. The problem A is I want to integrate cosine, arc cosine x dx here. Okay, so for the arc cosine x dx, right? So remember, we do the integrated by part, we want to divide the 1 is u, 1 is dv here. So in here, let's say here, we let the inverse function to be the u, and then here, the dx I will have to be the this here, right? Okay, so let me color code that. So the color coding is here. All right, so here, this is the U is equal to the arc cosine axis, right? And now in here, the dv equal to dx. So I take the derivatives, right? So this is the du is equal to, so I have this formula here. So it's -1 over 1 minus x squared. And then the purple one, as always, you take the integration. So v is equal to x here, right? Now I use the formula uv is here, right? So uv, okay, so this terms here will be uv. So it's x and the cosine inverse x minus VDUs, right? Minus VDUs here. Okay, so minus V, so it's V here, du. Okay, so here I should put a dx here. When I take the derivative, I need to have dx here, right? So now in here, minus VDU, so it's a -1 and 1 minus x squared dx. So let's just combine the negative sign first. So this is cosine -1x. This is plus x, 1 minus x squared dx. All right. So did you see why I want to set the arc cosine inverse to the u's here? It's because when I take the derivative, I have this 1 over 1 minus x squared, right? Then the v, I take the integration, I have x. So you immediately spot, you say, oh, I can use the u sub here, try to solve this, right? So in order to solve this integration, so let's say I said, okay, so I will do a u sub here. My u sub here, this is 1 minus x squared. Then the du, oh, so here, don't confuse with u here, right? This is a u sub. Let's make sure. Let's put a u stars here, would be better. So this is a minus 2x dx here, right? And now in here, because you only have the x dx, so I need to divide by -2 both sides, -2 both sides here, right? So I have 2 to -1 du star and equal to x dx here, right? Okay, so now by u sub, let's try to rewrite this ones here, right? So this ones here, I have -1/2 here. So I move the -1/2 here. And then inside here, because it's u sub, right? X dx is equal to du star. Then here, this is 1 minus x squared. So this is u, the square, du star, right? Okay, so now the du star, so u star, the square root is 1/2, correct? Okay, so now I can continue. So this is x arc cosine x, right? And then minus 1/2. Now I'm taking the integration of this one. So this will be -1/2 plus 1. And I have u star, the -1/2 plus 1 here, right? Okay, so now this one's here, this will be 1/2 here, this is 1/2, so you can cancel that. So of course, don't forget the capital C. So this is a cosine, arc cosine. So this one is canceled. So this one will just be the u star, the square roots, right? Don't forget C. So what is my u star? 1 minus x squared. So this is x cosine inverse x, and minus what here is 1 minus x squared plus c here. Cool? Right. So that's how we do the arc, like inverse trig function. So this is the arc cosine. So as you see, that's why the good properties here is because of all this have like the 1 minus x squared. And so that's why you'll be able to use the, the U sub later here, all right? Okay, so now let's take a look at the second province here. Okay, so the second province, the part B here, okay. So the part B is here, this will be the arctangents here, right? Okay, the arctangent, this is 2y dy. So the same strategies here, right? Okay, so the same strategy, okay, I'm going to put this part as my u and this part as my dv's here. All right, so let's try to do a little bit of color coding here. So u is equal to arctangent 2y and dv is equal to dy. So the green one, you take it into the derivative. Okay, so du here is equal to, so by using the formula from the previous page, it's 1 over 1 plus x squares, right? So, but it's a chain rules here. So this will be 1 plus 2y square, then chain rule, you have 2's here, dy's here. And then here, this is v is equal to y. And so let's kind of simplify this is a little bit. So this one's here, this will be 2 is 1 plus 4y squared dy. Okay, so now I know how to write it, right? So this will be equal to uv, right? So it will going to be equal to the uv is here. So this will be uv is y arctangent 2y, right? Then minus vdu's, right? So minus vdu. Okay, so minus vdu. So it's a minus, so let's put the 2 out here. And then here, this is vdu. So it's y, so it's 1 minus 4y squared. And what? dy is here. So as your detective eye, then you will see, oh yeah, that's another way I can do a u sub. See here. That's why for the the inverse trig functions, we assign that the inverse trig to be the u because I try to use the u sub. Okay, so now let's do the u sub again. So it's not get confused. I use a star. So this is 1 plus 4y squared. Okay, so the du start will be equal to 2 times 4 is equal to what? Equal to the ay and the dy's, right? So if you take a look in here, I only have a and the dy, so I need to divide it by 8, divided by 8, both sides. So I have a du start over a, and this is y dy's here. All right. Okay, so now let's try to rewrite this one. This is the tangent, negative 2y minus, so it's 2. I have this constants 1 over 8, so I take 1 over 8 out. And then inside here, 1 plus 4y squared is u star, so I put a u stars here. Then y dy is du star over 8. I already took the a out, so it's du star. Then the things become very beautiful here, right? So this is y tangent inverse 2y. So what is here? This is minus 1/4. Hey, the 1 over u star, what is this one? Is natural log of what? It's natural log of u star. And I put the absolute value, but doesn't matter, it's always here is positive anyways, right? Okay, now don't forget the plus c. So that's why you have a y arctangent 2y. So minus 1/4. What is here? Natural log what? 1 plus 4y squared. right? Plus C. Hey, it's pretty cool, right? So it's pretty easy to do here, right? Okay, so this is how do we do the arc, like the sine, cosine, tangent, the inverse trig functions here. Now, let's take a look at the last ones here. This one is a little bit more complicated, but that's, you know, that is what we are learning here, right? Okay, so that's good. So let's do a problem C here. The problem C, this is the arc sine. Wow, this is arc sine x to the square dx here. Okay, let's take a look. How do we do it? Even it's a little bit more complicated, but I will still be able to do that. So we put the arc sine here is u, and this is my dv's here, right? Okay, so now I know the u is equal to the arc sine x, the whole thing square, correct? Okay, so now dv is equal to dx. So this one is easy to integration, just be x here. So let's take a look at this one. So the du, right? So this first, I need to use the power rule. So this will be 2 arc sine x, 2 minus 1 become 1, see here. Then the chain rule about the arc sine. So what is the chain rule about the arc sine? So this is 1 over 1 minus x squared dx, see here, right? Okay, so now we can write it. So here, okay, so now it will be uv, right? So it's uv. So let's take a look. uv is here, it will be x here, then the arc sine x to the square. So uv minus vdu, right? So uv minus vdu, as always, we did the previous two. Okay, so minus vdu, so this 2 is a constant, so move the 2 out. vdu, this is arc sine x. All right, so then this is, I have v, so x, and this is 1 minus x squared dx here. So now you say, oh, okay, so x and 1 minus x seems this could be a u sub here, right? But then I have this arc sines here. So how do I solve these ones here? All right, so now, okay, so like we still, let's try to see how do we do this, right? So in here, I'm doing the u sub again. Okay, so you see my u sub here. So I have a u sub, like I put it a different color, and u star to, so you will not confused with the previous by parts. So this is arc sine. All right. Okay, so u is equal to the arc sines, right? And so in here, then you know the x is equal to what? Sine u stars, right? I'm trying to match all this value with u sub here. Okay, so now the du start, right? So the du start is will just be 1 over square roots 1 minus x squared dx. Okay, so now let's take a look here, right? So here, this part here, dx 1 minus x squared, this is du start. Wow, that's pretty good. This one's here, this is a sine u start, right? I will just get here. Arc sine here, what is here? This is u start. Wow, okay, so that means my whole, let's put this one, the one we already got, don't get confused, minus 2. So what is inside here? This inside is u star sine u star du star. Oh, let's, we learned that in the practice number 1. So this is a combinations of the, you know, the polynomial and the sine. So let's try to take a look. How do I do this, right? So I said, okay, so this is u star So take a derivative is 1, take a derivative is 0, and then this is a sine u star. Take integration is negative cosine u star. Take integration is negative sine u star. Right? We did this many times in the practice number 1. So it's positive, negative, positives, right? So these integrations, so I can get, okay, so I'm just moving this one out, and then later we can put it back, all right? So I'm just trying to put this one out. So this is u star sine u star du star. So this will give me negative, right? So this will give me negative u star cosine u star, and the minus minus is plus sine u star, right? Of course, plus a constant c here. Okay, so now we need to substitute back to the x here. So you see here, oh, sine u star. Hey, good job. I have x here. Okay, u star. What is u star? Hey, I have cosine. Well, what is cosine u star? Well, I have the sine u star. Okay, so I say, okay, so how do I find the cosine u star? Okay, so in here, you take a look at the triangles here, right? So if this is u star, sine is a hypotenuse, opposite of hypotenuse is x, so it's x over 1, so it's x over 1, correct? And then by the Pythagorean theory, what is this one here? This is 1 minus x squared. So now I know in here, because the cosine u star is what? 1 over x squared. So now I change everything back to the x's here. So I can rewrite this ones here. This will be negative arc sine x times 1 minus x squared. Correct? All right. Right, so then I have this ones here. This one is a plus, right? So this is just a sine u. So this is x here, right? So this is this integration. Okay, now I'm combining with my original integrations here. So this is x arc sine x to the square minus 2. This is a minus arc sine x 1 minus x squared, right? And plus x is here, of course, plus c here. So now my final answer, this is x arc sine, oops, I forgot the sign. Okay, so this is arc sine x whole thing square. Minus minus is a plus, positive, so it's 2 arc sine x times what? 1 minus x squared minus positive is minus 2x plus c. All right, so we got it. It's pretty cool, right? Okay, so this one is a little bit more tedious and a little bit more difficult than another one. But the basic principle is the same, right? So you start with integrated by part to assign your inverse trig function to the u and then the dv to the dx. And then after that, and then you probably need to use the u sub and then try to solve the remaining integrations here. So this is a very interesting problem. It's a little bit harder, but I guess you guys can, now you get it, right? So that's good. And so that's it for this practice. So don't forget to practice, practice, practice. And if you can find some other, like the inverse functions, inverse trig function problems, and go ahead and practice it. Practice make you getting better in the math. Okay, that's good. So our next practice set is practice set number 4. We're also going to talk about special patterns here, right? So we're going to talk about natural log functions or the log functions involved. And then how do I use the integrated by parts? And to do it. Okay, so looking forward to talk to you again in my next video. So make sure you practice this one. Like I said, this one is a little bit more tedious than the previous two practice sets here. Okay, nice talk to you. Have a good day. Bye.